So the concept of getting this three-way communication means that what we're trying to establish from both PCs' perspective is the fact that each PC knows that two-way communication is possible. Now, this only guarantees two-way communication at that moment, but still nonetheless. So PC1 sends out a message, goes out of his network card, and it's a send message. The layer 3 information will get that information over to PC1. Now, when I say the layer 3 information, we're talking about the layer 3 information that has encapsulated the data itself. In this layer 3 header, we're going to have the destination IP address, or where we want to go to. So this send message is now our data, so to speak, and that send message is coming over to here, to PC2. Now, when PC2 gets this information, what has this proved at this point? Nothing. The send message actually comes into PC2. All this means is that PC1 has received information. From PC1's perspective, he has no idea if that PC has gotten it. From PC2's perspective, he knows at least data is coming from that PC. So at that point, he would know one-way communication is possible, and that one-way communication would be from PC1 to PC2. So what PC2 is going to do is send out another message over to PC1 saying, I got your sync message, and here's my acknowledgement of that sync message. Now, this is interesting because what this proves at this point, PC1 knows he sent a message out, and he knows he got a message back from that person he sent it to. So now PC2 knows two-way communication is possible. He knows this, but PC2 doesn't. All PC2 knows is that he got data from the source and sent data to the source. He has no idea that PC1 got the acknowledgement that he sent out. So now, because of that, that's where the third handshake comes into play, which is a message coming from PC1 that is just an acknowledgement. Now, this is awesome, because at this point now, PC2 also knows two-way communication is possible. How? Well, PC1 knew that two-way communication was possible when he sent out the send message and got a sync act from PC2. PC2 knows that he has two-way communication. How? Because he sent out a sent act message and got an acknowledgement back. That's how. So now both these PCs know that we have two-way communication. Once the three-way handshake is done, now we can begin our real transmission. Which means if I was trying to send data of just ABC from PC 1 to 2, I just want to say, hey, let's make it a little bit more personal. I want to tell PC2, hello. I want to say, hey man, how you doing? Well, before I send this message, PC1 needs to make sure we have guaranteed information, because I want to make sure that this hello message is guaranteed. I want to make sure PC2 gets this hello message. So before I send hello message, this process begins. We send out our send, then we get our send act coming back to us. This tells PC, well, I know when I sent the message, I got to send act back from that person I was sending it to, so two-way communication is possible. PC2 starts to guarantee his two-way communication once he sends out the send act message. And then when PC1 gets back an act, that means two-way communication is done. You can look at it in two ways. You can say that PC2 is actually sending him an acknowledgement of the synchronization, or you can say, I'm acknowledging your send, but I'm going to send you a send myself, so please acknowledge it. Because from these two perspectives, PC1 is saying, look, I'm going to send you a send message. Once I get an acknowledgement back from you, I know it's two-way. So PC2 is going to say, I'm going to send you that acknowledgement so you can guarantee your two-way, but I'm also going to send you a SYN waiting for an act from you so I can also guarantee my two-way communication as possible from my end. You can look at it from that perspective as well. Or you can look at it and say, look, I'm just, I am focusing on the fact that I'm sending you an acknowledgement of your synchronization that you're trying to do with me. Either way, as long as you understand that this must take place, SYN act, and acknowledgement before this hello even can be sent, that's the key factor there. Now, all this is very important to know because your transformation, and I keep wanting to say transformation, your transmission, and I apologize that I keep doing that, but your transmission is never possible of the actual data that you want to send until this three-way handshake is established. Remember, this is for guaranteed delivery, which means if this was just best effort, this hello would never go through this three-way handshake. It wouldn't even try. Who cares? I'm just going to send it out. But there's no guarantee he's going to get it. So this must be successful. The three-way handshake must be successful before data is sent. If one of these messages never gets back, two-way communication is not possible, either from PC's 1 perspective or PC's 2's perspective. And if that's the case, it's not going to happen. Eventually it'll time out, and PC 1 will try to send the information all over again. And this will keep going until the application itself or whatever's trying to establish these flows will time out. If there is no timeout value, guess what will happen? Well, it'll just keep on going forever. Now, Windows has these establishments. This allows me to see all the information that's going on my machine right now. This is a TCP trying to be established. And it's showing you here, from this IP address, which is my PC here, here's this random port number I was telling you about, 53493. That's a random port number. And it's going to this particular IP address with 8080. And it's telling you that we sent a send message, which means we're trying to set up a TCP session with this. Now, there's other messages in here with TCP. You can obviously go out there and look them up. It's pretty cool. It's nice to know what's really going on with TCP. But you also have these established connections. This is telling you that the TCP session has been established. It's telling you that over here it is a TCP session. It's telling you it's been established. Once it has been established, data can flow. Here's UDP. You know, it's just UDP traffic. It's just telling me, look, I just got UDP. Was that going to my address? I was being sourced. Just being sourced from my address. So here, you can also see some of the ports that we're listening on. Here's a port I'm listening on right now. TCP port. It's good to know what your PC is listening on. You might have ports that you really don't want to open. This will allow information to come in. You might want to do a research on every port that you have that you're listening on to find out what they are. You might find out that these are viruses. You might find out that it's malware. You might find out this is a port that someone is open. You don't really need it open, and so you go out and you close it. Now, just because it's open and listening on this PC doesn't mean that you can't block it. You can always go in your router and block it. You can also find the commands to make sure that this PC is no longer listening on those ports as well. But once you start getting into this game, make sure that you're aware of what you're doing. You might shut down something that you actually need. So let's talk about these random port numbers. Imagine me going out to a web server. No matter what type of communication I'm going to do, remember guys, we have to build out layer 2, layer 3 information. But since we're trying to communicate with a particular port, since we're using web service, we're also going to have layer 4 information. So, when I'm trying to communicate with a web server, I'm going to send my data. But I'll take this data and I'm going to encapsulate it with what? Layer 4. That layer 4 information is going to have my source port, my destination port. Since it's web, that destination port is going to be 80 or 8080 or 443. Now my source port is going to be a random number, just like you saw in my netstack command, showing you all the ports and all the ports that we're listening on, and all the TCP sessions we have established, and so on and so on. That source port is just a random number. 58,212. Now, next time he goes out to send something, when I say he, I'm talking about Windows. The next time Windows goes to send out something, he's going to use 58,2013. He's going to use whatever the next available port number is. That's why we call them random numbers. And that information goes out, because obviously we're going to have the layer 3 with the source and destination IP. And then we're going to have the layer 2 with the source and destination MAC. And this information is going to go out over to the web server. The web server is going to look at the destination MAC and say, oh, well, that's my MAC address. I'm going to go ahead and remove that and take a look at the IP information. Oh, that destination IP, that's for me. And look at the layer 4. Oh, that's port 80. Well, that goes to my web service. Now, just because we have one server sitting here does not mean that it's not doing several types of services. So when this server gets that information and see that it's coming in on port 80, he's going to send that over to his web service. That belongs to my web service. This traffic, as it's coming over to the web server is going to send it to its service, web service. And now when he goes to build the information back, because eventually he's going to look at this data and say, hey, this is a request for information. Let me send that information. So the information he's going to send is going to be what? The data. He's responding to the request. And this is the response. He's going to send data back, which is going to be the response. He's going to build his layer 4 information. And what's that going to be? The source port's going to be obviously himself, which is 80. And the destination port is going to be the source port that came in on the packet in the first place. 58212. Now this makes sense, because if you're going to send out an envelope to someone, they're going to have the address sitting here, 123 Fake Street. And then someone's going to have their return address up here. And we'll say No Avenue. Now this really makes sense, man, because this is the address that it needs to get sent to. When I received this letter coming to Kyle over here, when I received this letter, I don't have to ask them where to respond. I get a request for information. I'm going to respond to that information, and I'm going to build my envelope of my own. And I'm going to take whatever the source information I saw in the letter and put that as my destination. 567 No Avenue. And then my address goes up here. 123 Fake Street. So this makes sense. The information that he got when the packet came in is going to be the information he's going to use to send the packet back. So now he used a destination port number of 58212, builds his layer 3, builds his layer 2, and sends the data on. That information comes over to here. PC1 says, well, let me look at the layer 2 information. That belongs to me. Let me open it up. Oh, let me look at the layer 3 destination information. That belongs to me. Let me open that up. And then there's the port number. 5812. Oh, well, I know where 58212 goes to. That was that web page that I had open. So this is awesome, because if I have 10 web pages pulled up, just all cascading here and all just sitting here, right? If I had all these web pages up, and this was port number 60 and 70 and 80 and 90, well, anytime something was coming in on port 90, it's going to go to this web browser. It's not going to go to these three. It's going to go to this one. Did you ever wonder why, if you had like 20 web pages up, how it always ended up getting to the same one? Well, now you know. Port numbers. But remember, none of this communication is possible until our TCP three-way handshake is established. And that is really good to know. Because if you can't send data, most likely you got a TCP issue. So check it out. I'm not going to say most of the time, but it's definitely something you need to understand is going in the background. The last thing you want to try to figure out is do all these things and rebooting and so on, and realize that your TCP session is never being established. And that's why you can't get communication. So let's take a look at the TCP header here. The TCP header is pretty interesting. We got the source port, which we know now is random for Windows. In most cases, it could be a static port number. If you only want to communicate from this particular port number and you source it from that port number, the application can do that. So obviously, it knows to come back to that information, to come back to that particular service. Here's the web server. When it actually got the data coming in on this web server, he used this random source port number he might have gotten, but he used a static source port of his own for 80 when he sent the data back out. So it's not always random. We have a destination port. Obviously, if I'm coming from my Windows and open up a web browser, my source port's going to be random. And my destination port going to a web server is going to be 80. If I was communicating with a TFTP server, it'd be 69. If I was communicating via Telnet, it'd be 23. If I was using SSH, 22. Does that make sense? All depends on where you're going and what you're trying to accomplish. Secret numbers and acknowledgement numbers, we're going to be looking at that later on. And window. So this is interesting because remember, this is not source IP and destination IP. Guys, this is just layer 4 information. So when I have a piece of data here, I'm going to encapsulate this data. Now, what does encapsulation really mean? Let's think about that. Our encapsulation means that here's my data. I'm going to put information in front of it. I'm going to put it in this box.